After completing the terminology total depth, next one is backlash. So backlash is the difference between the tooth space and the tooth thickness measured along the pitch circle. Here, please make a note, students. Theoretically, the backlash should be zero, but in actual practice, some backlash must be allowed to prevent jamming of the tooth due to its thermal expansion or tooth errors while measuring. Next, tooth thickness. It is the width of the teeth measured along the pitch circle. What is that? It is the width of the teeth measured along the pitch circle. Next one is tooth space. So it is the space between two adjacent tooth measured along the pitch circle. See, pitch circle is very important in the gear. Now, face of the tooth. So it is the surface of the gear above the pitch circle, and flank of the tooth is it is the surface of the gear below the pitch circle. So these are all terminology of spur gear. Now next we will see very important point, that is law of gearing. So law of gearing, this is used, or you can say it is a condition for constant velocity ratio. So here I have drawn the figure of the two gear teeth. Here I have mentioned gear 1. So this is the teeth of gear 1. Let us consider, and this is the teeth of gear 2. Here you can find O1 is the center of teeth of gear 1 and O2 is the center of teeth of gear 2. Here, when two teeth are meshing at a point, see here, through that we can draw a tangent and exactly perpendicular to this tangent. So n dash is the normal. Here I have mentioned the angle alpha. Here you can find the pitch circle of gear 1, and another one is here, this one, this is the pitch circle of gear 2. When two pitch circles are meeting at a particular point, that point is known as pitch point, and that is denoted by P. Here, so by geometry I have drawn the triangle. So let us consider this is O1, M and K. Here point of contact I have mentioned, that is K. Another one is O2, K, N. See here, so this point N is on normal and this point M is also on normal. So you will find M, K, P and N, it is on the same straight line. Here alpha is the spiral angle. Here also alpha is the spiral angle of another gear teeth. Here I mention another angle is beta. Why? From point of contact, see, let us draw a line. So which is a line showing the velocity of gear 1, which is exactly perpendicular to O1K. See here. Another one is here V2. I drawn velocity of gear T2, and this V2 is exactly perpendicular to O2K. So I have drawn one a line through normal, perpendicular to normal. So these lines are meeting here, and we can find a various triangles. Now we will see exactly law of gear. So we have considered two gear teeth meshing with each other, and point of contact is K. V1, V2 with the velocity of point K when considered on gear tooth and 1, gear tooth 1 and 2 respectively. So now common velocity along n dash, that is equal to K n dash. If you consider gear 1, so it is V1 cos alpha, and common velocity V2 along n dash is K n dash, and that is also equal to V2 cos beta. So these are the two equations we got. Now if the meeting teeth remain in contact while transmitting the motion, then component of this velocity along common normal must be equal. So by this condition, we equate equation number 1 and 2. We will